So, for the do now today, the question is how would you try to solve this problem? And the problem says during an experiment, the same type of bacteria is grown in two petri dishes, which usually circular dishes. Petri dish A has a diameter of 51 millimeters and has approximately 4,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and approximately 72,000 bacteria after 1 hour. Pictures. And then determine and state which petri dish has the greater population density of bacteria at the end of the first hour. So, basically, the point is there's a lot of information right here, and there's a lot of keywords. So the question is, and what we're going to look at today, is how would you break down problems like this to make it a little bit easier to solve? We're not going to solve it right now because we're going to solve it throughout the lesson. So today we're going to be modeling problems, more complicated problems like the ones we had in the Do Now. And I'm going to teach you a strategy called the 3-read strategy. And it can really help when you get a whole lot of information and it becomes a little more complicated to deal with. So, for any long, complex word problems like this, I always suggest using the 3-read strategy. And what you do is you read the problem the first time. And when you read it the first time, all you want to think about is what is going on. What is the situation asking about? What is like the final thing asking us to solve? That sort of thing. Number 2, what are the quantities? And quantities is an interesting word. So quantities includes both a number and a unit. So you need a number and you need a unit for these. And then, when you read it the third time, what you want to do is you want to create a plan. Figure out how to solve it. And then, of course, solve it afterwards. That's not quite, a step 4. But with each one of these steps, read the problem again. So read it once. What's the situation asking about? Read it a second time and underline or highlight all the quantities you find, because the quantities are going to be good to use to solve the problem. And then read it again and figure out what's a plan to solve the problem. So, first thing we're going to do is we're going to read through the situation and figure out what is this even asking about. So, during an experiment, the same type of bacteria is grown in 2 petri dishes. It's important. 2 petri dishes, same bacteria. Okay. Petri dish A has a diameter of 51 millimeters and approximately 40,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and approximately 72,000 bacteria after 1 hour. I don't really feel like we're getting there. Determine and state which petri dish has the greater population density. Which petri dish has the greater population density of bacteria at the end of the first hour? So basically we want to figure out which one of these has a more dense collection of bacteria. All right, now we're going to read through again, and we're going to highlight all the quantities. And remember, the quantities are the things with numbers and units. So during an experiment, the same type of bacteria is grown in 2 petri dishes, which I guess we could highlight 2 petri dishes, but I really don't think it's going to be helpful. We can obviously see there's 2. Petri dish A has a diameter of 51 millimeters. That's going to be important. And approximately 40,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and approximately 72,000 bacteria after 1 hour. Determine and state which petri dish has the greater population density of bacteria at the end of the first hour. So these are all the quantities that we're going to use to solve the problem. And right now, I already can tell that this is looking a lot simpler here. We only have 6 things, and it's really 3 things for each one of the 2. Okay, so now we're going to make a plan and we're going to solve this problem. So here, during an experiment, same type of bacteria is grown in 2 petri dishes. Petri dish A has a diameter of 51 millimeters and approximately 40,000 bacteria after 1 hour. Petri dish B has a diameter of 75 millimeters and approximately 72,000 bacteria after 1 hour. Determine and state which petri dish has the greater population density of bacteria at the end of the first hour. So, we're trying to find density. And hopefully you guys remember that density is how compressed things are. So if you think, we live in New York City where it's a very high population density. There's a lot of people per square mile. But if you go live in the country, kind of where I grew up, then you have very few people for every square mile. Hey, you might even have 1 or 0 in a given square mile. But in New York, there's thousands. So what we really want to do is we want to take the population and divide it by the area that we're looking at. So first we have to figure out the population and we have to figure out the area. So for A, the population is 40,000 bacteria. And for B, the population is 72,000 bacteria. Now, with this, you see where it says the 1 hour part? This 1 hour as a quantity really doesn't matter because they're saying at the end of 1 hour, or the end of the first hour in the question. So essentially, this is not helpful for us. It just gives us a way to compare them so that it's standardized. So what we need to do now, we need to find the area of these. And in order to find the area, we're going to have to use the diameter. Now, of course, if the radius is 51, we have to divide that by, if the diameter is 51, we have to divide that by 2. The radius of this is going to be 25.5 millimeters. And the radius of this, divide that by 2, of course, is going to be 37.5 millimeters. So to find the area for A, we're going to do, it's a circle, so we're going to do pi times the radius, 25.5, squared. And for B, we're going to do the same thing. We're going to do the area equals pi times the radius, 37.5, squared. And now we go ahead and use our calculators. And when you use the calculator, you get that the first area is about 2,000 and the second area is about 4,400 square millimeters. So finally, to solve this actual problem, what we need to do is we need to do the population over the area. So in the first one, we're going to do 40,000 divided by 2,042.82. And for the second one, for the population over the area, we're going to do 72,000 over 4417.86. And again, calculator time. And we get that the first population density is 19.58 bacteria per millimeter squared, and the second one is 16.3 bacteria per millimeter squared. So to finally answer the question, we want the greater population density, and the greater population density is A. So you would say Petri dish A has the greater population density because 9.58 is bigger than 16.3. So, time for you guys to work on a couple problems on your own. At the end, I want you to think of 2 things that you like and 2 things you dislike about using this strategy of reading it 3 times and looking for specific stuff each time. And don't forget, your homework is due at the beginning of class on Friday.